So welcome everybody. Today we are going to do mathematics. This is our first lesson. Now on this lesson we're doing 3 and 4. So we start with book 3. This is from 4 book 3. Kenya Literature Bureau. Students book 3. In this series of hopefully wrong series of mathematics series, we are going to cover mathematics that are going to help students do this year KCSE exam in mathematics. The other book is book 4, the same publisher, Kenya Literature Bureau. Okay. Now then we are going to be using revision books. And the revision book I've chosen is C. Muturi, and you have the C. Muturi from 1 and 2. These are very important books. In my time, there was only one C. Muturi, which actually helped me a lot in passing my mathematics with a straight A. Now, we also have this C. Muturi, solving problems, KCSE mathematics paper 2. Yeah, so anybody who wants to follow along with us, with me, can also get these copies so that he can be able to go ahead with the calculations properly and see how they can be able to pass their KCSE exam. Okay, so now the first topic we'll cover quadratic expressions and equations. Okay, so quadratic expressions and equations. Now this is what I want us to look at, quadratic expression and equations. Now number 1 will be doing the factorization of quadratic expressions. Number 2 will be doing the perfect square. Number 3 we'll be looking at the completing the square, to complete the square. And number 4, we'll be checking or working on the solutions of quadratic equations by completion of square method. And then the other thing we'll do is the quadratic formula. We need to look at the quadratic formula, formation of quadratic equations. How do we form quadratic equations? Now graphs of quadratic functions. We'll check now how to solve quadratic equations and expression using graphical methods. Now we also have the graphical solutions of quadratic equations. So both are the same, I think, what I've just said. But one is for the graphs of quadratic equation, how to draw them, and then the second one is the solution, how to get solution using graphical methods. Now the other one is also graphical solution of simultaneous equation. So quadratic expressions and equation. Let's start with what is an expression. So an expression is any mathematical arrangement that doesn't have an equal sign. Okay, anything can be an expression. A plus B or 2A. Let's see as expression. Expressions. So you can have an expression 2A plus 3C. That's an expression. We don't know what is A and what is C. We only know that there's 2A and 3C, but beyond that we are not given any more information. That's an expression. Okay. Now an equation is that expression that has an equal sign somewhere in it, not specifically on any side, but anywhere we have that mathematical arrangement that has an equal sign, then that becomes an equation. So we can talk of 2A plus 3C is equals to 10. Okay, so for example, here you can say A is a hen and C is a goat. So 2 goats plus 3 sheep will cost you $10, 10 shillings, or whatever. So that is what we call an equation. Now when you talk of quadratic, so this is an equation. This is an equation. That's an equation. Now when we talk of now quadratic, a quadratic expression or equation is that which has this format: x squared, okay, ax squared plus b just a minute, plus bx plus c. Okay, so now this is a quadratic expression. Now when we add an equation, an equal sign, we give it a number. Maybe let's start with 0. Now this become an equation, and this is an expression. So you have those distinct terms there. Expression. Okay, so this is an equation, this is an expression. Okay, so let's look at the first thing with the factorization of quadratic expression. So I've already now expounded on quadratic equation and expression, what an equation is and what an expression is. I hope you already knew that. A factorization of quadratic expression. Factorization, number one, factorization of quadratic expression. So we have an example which is number one of x squared plus 6x plus 9. So now when you talk of factorization, we are talking of putting this expression in its simplest format. Now let's look at this. Let's see how we do that. So, factorization of quadratic expressions. Now I'll use this example here. We've just written x squared plus 6x plus 9. Now what we do is that we have our a, in this case is 1, our b is equals to 6, and our c is equals to 9. Note that here ax squared plus bx plus c, abc are numbers. So now what we do is that we check the product of a and c. Okay, that product. For example, now here we have 1 times 9, which is 9. Now which of those two numbers that when you multiply them you'll get 9, and when you add them you'll get 6? Which are these two numbers? Factors of 9, now 1 times 9, we have 3 times 3, 4.5 times 2, all those. But now you realize that 4.5 times 2 will not give you 6 when you add them up. Okay, so we narrow down to what we had before, 3 times 3. So now we have x squared plus, now 3 times 3 will give us 9. Now 3 plus 3 will give us 6. So we have the same expression here, and the same expression here written using 3x doesn't change anything. Both will give you 6x plus 9. Okay, and then we factor out. We can start on that end and then go to that end. Okay, so we factor out whatever we have in here, which is x x plus 3, and then plus 3 into x plus 3. Note that 3 times 3 will give us 9. So we can find that here we have some commonality here, and therefore we can write this as x plus 3 into bracket, then this one x plus 3. And finally, you find that we can write this expression of x squared plus 6x plus 9 as, now this can be written as x plus 3 squared. So you find that all these equations can be rewritten in a simpler format of that. Okay, so if x was 2, you find that you just need 2 plus 3 squared, which is 15. Now compared to coming all the way 2 squared, that is 4 plus 6 times 2, 12 plus 9, again is 25. But you've gone you've gone through hassles getting that 25. So this is the simplest format of writing that quadratic expression. Okay, so they're the same. Now an example that so this is what we call a perfect square. This is what we call a perfect square because it can be written in the form of one of these terms squared. Well, these two terms are similar, so you can square them to get to there. Okay. Now we have expressions that do not behave the same, and those we do not call them perfect square, but we can still write them in the simplest format. For an example is page 1, number 4. Example number 4, 1.1, factorization of quadratic expressions. We have x squared plus x minus 12. Okay, so this one is not a perfect square, but you still need to go ahead and simplify it. Write it in the simplest form. So you find that now again the drill is the same. A is equals to 1, b is equals to 1, and c is equals to minus 12. Note that is this minus 12. Okay, so here you have AC is equals to minus 12. Now which factors or which numbers can we multiply to get a minus 12? And when we add them, we get a 1. Okay, so you have 3 times 6 times 2. Okay, let's start with 12. 1 times 12, 6 times 2, 3 times 4. Okay, so what else? I think we are done. So what happened is here we have a positive x. So we can effectively say that minus 3 times 4, that will give us minus 12, and minus 3 plus 4 will give us a 1 here because b is 1. So you can comfortably write the same as x squared minus 3x plus 4x minus 12. Okay, we don't have an equal sign, but now this is completely the same as that. Complete same. So let's factor out this. So we have x minus 3 plus 4x minus 3. So if we put these brackets together, we have x plus 4 x minus 3. So we find that this is not equivalent to that. Therefore, this one is not a perfect square. That one is not a perfect square. This one here is a perfect square. But both, you can put them in their simplest format. So we have already said that a perfect square is that expression whereby if it is reduced to its simplest format, and I still use the same example, you can go ahead and use the other example given in the text. So we are saying that for the what perfect square, x plus 3 squared. So that's a perfect square which will culminate to x squared plus 6 x plus 9. So either way, this is a perfect square by virtue of us reducing it to give us that format. So that's a perfect square. Now let's go to our paper and see how far we have gone. Let's see completion of square. What do we mean when we say completing square? We may be given an expression, and you're told to make it a perfect square, and you're having this example of x squared plus 10x. Okay, we have x squared plus 10x. Now there's something I want us to see, that always we have this expression. Allow me to use this. X squared plus 6x plus 9. We want to make that one to be a perfect square. So we said that if we write this one in the format of is ax squared plus bx plus c, okay, then you're saying that ac, okay, over 2 squared, sorry, get it wrong, that b over 2 squared is equals to AC. Sorry for that. It's B. B over 2 squared is equals to AC. Right? So, if you're now given this problem here to solve, we are told x squared plus 10x, we make it a perfect square. This is a, this is, okay, our a is equals to 1 and our b is equals to 10. So what do you think you're supposed to do to get a c? So it's simply to come to b over 2 squared to get to c. Now we put the numbers here. We have 10 over 2 squared, that gives us 25. So we have x squared plus 10x plus 25. Now this one is a perfect square. You can go ahead and reduce it and you'll find that you get a perfect square, okay, which is x plus 5 squared. Do that using the other method we said and you'll find that you get x plus 5 squared. So let's go on. Now we have looked for a very simple example here of x squared plus 10 plus 25. Now we may want to check the other terms, how you can go about to get them. Now for example, and I'm keeping using examples to make it as simple as possible. Yeah. So you have 25 x squared plus dash plus 9. I want to make it a perfect square. So which term must be added here to make it a perfect square? So our a is equals to 25, our b is equals to unknown, and our c is equals to 9. So application of the formula without even thinking. B over 2 squared is equals to AC. Now our AC is, okay, so B over 2 squared is equals to AC. So now our AC, I've said, is 25 times 9, which is 225. So b over 2 squared is equals to 225. Okay, so now we have b over 2. B over 2 is the square root of 225. Therefore b over 2 is equals to plus or minus 15. Square root of 225 is 15. Okay, so b becomes plus or minus, take 2 to the other side, 30. Okay, so it can be a plus or a minus 30, and therefore the missing term here is 30. We have 25x squared plus or minus 30x plus 9, and we have 25x squared minus 30x plus 9. Get that, get those perfect, or those simplest format of writing this, and find that they are perfect square. So I'm just hoping that you have found that those the simplest form of either of these should be 5x plus 3 squared, okay, or 5x minus 3 squared. Either of that, this tarry that, and that tarry with that. Now finally, I think we'll be checking our last example. Our last example where the missing term is the first one. So, and I'm still going ahead and using these examples in the text. Now we have a dash. Let me bring this closer to you. Yeah, a dash minus 40x plus 25. That's 40x plus 25. So get the first term. So how do you go about it? Again, just bring your b over 2 squared is equals to ac. Okay, we already have b is 40, right? We already have that b is minus 40. So minus 40 over 2, that gives us 20. Okay, minus 20 squared, minus 20 squared, that will give us AC. Now our A is unknown and our C is 25, so we have 400 will give us AC. Now C is known as 25, so A is equals to 400 over C. Okay, 400 over C. Okay, so C is 25, so A becomes 400 over 25. Now if you divide 400 by 25, then you get 16, so our A is 16. So our equation, our expression will be 16x squared. And note that we are talking about the first term being x squared, the second term being x, the third term having none of x. So when you're getting this term, the term is not 16, but the term is 16x squared. So minus 40x plus 25. If you do that, you should be able to get a perfect square. Okay, should be able to get a perfect square. So if you calculate it properly, then you'd find that the term in the perfect square, or the simplest form of these, will be 4x minus 5. That is gonna give you that. So that is simply what we say. We'll say what about, that is simply what we'll say about the compression of square, getting the term, the missing term, to make the expression a perfect square. So our next thing will be solution of quadratic equations by completing the square. This is our second thing. This is our fourth thing that we'll be working on. So let's go ahead. So before we move on and forget where we started from, I want us to check two of the sample questions that we can have in our exam, mock, KCSE, or things like that. So want to cover piecemeals. Okay. So you can see we are talking about Simoturi paper 1, this book, from 1 and 2, page 166, number 2. We have this problem, and it's 2x squared minus x minus 3. We're taught to factorize completely. So what we do is that we want to write this in the simplest format. Okay, we want to write it in its simplest format. Let me write the page. This is test paper 12. Test paper 12, page 166. Page 166. So 2x squared minus x minus 3. So you find that what you have learned, you can very easily get 3 marks here, because here now we have our a is equals to 2, b is equals to minus 1, and c is equals to minus 3. Note that this doesn't have to be a perfect square. Okay, so what we do is that we say our AC is equals AC is minus 6. Okay, what are those numbers that if we multiply we get minus 6? Okay, which are those numbers if we multiply together will give us a minus 6, yet when we add them together they'll give us a minus 1. B is a minus 1. Okay, and you find that coincidentally there is only 2 and 3, so we can write this as 2x. We can write it as 2x squared minus and this is not minus 2 and 3, it's minus 3 and 2, so that we have this x give us a minus x. So we have minus 3x plus 2x minus 3. Okay, so finally you can come and factorize 2x here at the end. We do that after that. Okay, so you have x minus 3. Okay, no. Oh, sorry. That cannot be the case. We'll take that factor and that factor. I'm sorry. So you have 2x. So here x minus 1. If we take this, that is minus 1. Okay, and then minus 3 into x minus 1 when we talk of 3x and 3. I'm sorry about that. So finally you find that we have 2x minus 3 into x minus 1. So you can see that is not a perfect square, but that is how we have factorized this to get minus 2x minus x minus 3. This one is equivalent to having that. So you can see those are 3 marks. Yeah, so just check this. This we have done a minus 3 here, and minus 3 times this and this. So minus 3 into bracket, this should be plus, so that we get a minus. This should be plus. I'm sorry about that again. So this should be plus. Just counter checking with the answers. but basically the point is the same. And again, we also have the same question. They're happening on 166 and 199. So we have test paper 18, page 199, and again we have the same number 2. We have 5x squared minus 9x plus 4. Okay, so again we go ahead. Our a is equals to 5, b is equals to minus 9, and c is equals to 4. Okay, so what is our AC? AC is equals to 20. Okay, which are those two numbers? When you multiply you get a minus 9. I mean, when you multiply you get 20, and when you add them together you get a minus 9. Coincidentally it's minus 5 and minus 4. Very simple. So here you go ahead and say x squared, 5x squared minus 5x minus 4x plus 4 is equivalent to that, which it is equivalent in the actual fact. So then we go ahead and factorize the like terms here. For example, we have a 5x, and then here a half x minus 1. Okay, we have an x minus 1. Okay, now then we go ahead and talk about a minus 4 here, minus 4. So we have x should be minus 1, so that you get minus 4 times minus 1, you get 4. So this is minus 1. So we have 5x minus 4 to bracket x minus 1. Okay, so again you find these are supposed to be 3 marks, and these are 2 marks. Can make a difference between getting an A and a B, yeah, and can remove you from getting a D.